Episode 202 of CppCast with guest Michal Kovařík, recorded June 10th, 2019. Sponsor of this episode of CppCast is the PVS Studio team. The team promotes regular usage of static code analysis and the PVS Studio static analysis tool. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at jetbrains.com. In this episode, we discuss documentation tools and fuzzing. Then we talk to Michal Kovařík from Woob Software. Michal talks to us about the Factorio video game that his team is building with C++. Welcome to episode 202 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm doing all right, Rob. How are you doing?
Doing pretty good. Don't have too much news to share myself. You?
No, I actually don't think I do either at the moment.
Okay.
That's kind of weird, huh?
Yeah, you always got something going on.
Yeah.
Okay, well, we'll jump right to some feedback for the week. And this time, we just got a tweet from Bigaloo, and he's saying, listening to CppCast has now become a habit, makes my train journeys worthwhile. So, yeah, glad you're able to do something slightly productive during the train ride. Glad you're enjoying it.
You know, I have had a few people complain to me at conferences that they're like, I discovered CppCast, 8 months ago, and I've been listening to an episode every day on my commute. And now I'm out of episodes.
Yeah.
And now I have to wait. And I'm like, I'm sorry. I'm not sure what to say about that. But maybe this is just a warning. If you're picking up the podcast right now, maybe pace yourself a little bit. Don't just binge them all, because you will run out. We don't have thousands of episodes or anything.
I mean, you kind of have to binge them a little bit if you just started and we got 200 episodes out there.
Well, yeah, but I mean, do a mild binging, like 3 or 4 a week, not like 5 to 7 a week or something like that.
Yeah, that's good advice, because I don't think we're ever going to be doing more than one a week.
No, I don't believe that. No, yeah.
Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Michal Kovařík. Michal is 34 years old and started programming when he was 11. C and C++ became his favorite languages soon afterwards. After quitting university, after 2 years, he was a regular programmer in a company for 4 years. He then started his own computer game project, which he's been working on for 7 years already. The game is much more successful than originally anticipated, with more than 1.7 million sales while still in early access. And they are close to finishing the game and deciding what to do next. Michal, welcome to the show.
Welcome. Hello.
We'll definitely talk more about the game in a moment here, but I'm curious what computer system you started programming on. I'm looking at this probably mid-90s, is that right?
It was 286.
Okay.
It sounds familiar, yeah.
Yeah.
And we called it a Blue Sea. I don't know if you know what it is, the Borland, I think it was the Borland Turbo C or something like that.
Right.
So that was the beginning.
And so that was a 286 DOS then, I guess, probably.
Yeah, DOS and text mode and 320 by 240 pixels graphics modes, etc. Yeah, it was fun time.
Do you ever miss... Oh, sorry, go ahead.
We had, especially in these times when we started, as is one of the things why we liked programming so much, that in the school, we had a rule that we couldn't normally play computer games in the computer laboratory, but with the exception that you could play games by people that were created by people from the school. So when someone made a game, he didn't have to compete with the worldwide competition, but we were only competing with games of other people from the school. So it was much easier to actually make people play our games, and it worked really well. It was really fun. So we made at that time we made several small games, and people played it like crazy. So it was nice times.
Sounds like a really. I'm sorry, I keep interrupting you.
Yeah, sounds like. No, what did you want to say?
Oh, it sounds like a really creative way to make sure that people are, creating games and what am I trying to say? Like encouraging people to be creative. That's what it sounds like.
Yeah. So, and at that time I was already doing things in C. It was I don't know if you wanted to initialize a graphic small, we just have these sacred 3 assembler commands that you wrote, and then the graphics magically started working. And I remember I was trying to do a game, and we had to do from everything. I made a simple graphical editor, and then small graphics library to draw pixels and lines, and then everything, and you had to do everything from very, very scratch. So it was rough, and it was really hard to get anywhere, because when you finally get a simple game prototype, you were already sick of it, and everything took really long. But I think it taught us a lot.
Do you ever miss the days when you were just talking directly to the hardware like that?
Well, not really that much. I mean, this is not the part that I enjoyed. It was just that obstacle that I have to go through, the pain I have to go through to actually express the things I wanted by the language. So I'm not this kind of guy who enjoys going deep just for the sake of going deep. I only do it for the benefits, basically.
Okay, cool.
Okay. Well, Michael, we got a few news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about the game you work on that you were just referencing. Okay, so this first article we have is not really an article, but we've been looking forward to C++ Now 2019 videos being available, and it looks like they're starting to come on. It looks like they've posted 6 videos so far. 3 came out on Friday, and it looks like just 3 more came out earlier today, Jason.
Yeah, at a weird time, midnight in the US, basically.
Yeah.
I wonder who is posting them.
Yeah, I don't know. But, we've made a couple references to C++ Now. We recently had David Vandevoorde and Michael Park on the show, and both of them gave C++ Now talks. So looking forward to those coming online. I haven't actually watched any of these yet. Have you, Jason?
No, I haven't had the chance to yet.
Okay. Yeah, I want to see some of these. I mean, we also had Chris Jusiak on recently. One of his videos is here, Dependency Injection, a $25 term for a 5-cent concept. Yeah, I'm sure there's some good ones here.
Yeah.
I'm sure they'll keep uploading them day by day.
Yes, I'm sure they will.
Okay. Next thing we have is a post from Simon Brand on the Visual C++ blog. And this doesn't really have much to do with Visual Studio at all, but it's clear functional C++ documentation with Sphinx plus Breathe plus Doxygen plus CMake. And I, was familiar with Doxygen, but I had not heard of Sphinx or Breathe. So this is a pretty good article for learning some more about new, ways to document your code, new tools to do it.
Yeah, I read this and I'm like, oh my goodness, Simon, do you really expect us to do all of this? But the TLDR on this is when you get to the bottom here, if you do all this boilerplate stuff, then you can get your documentation automatically generated on the Read the Docs website for each commit.
And if you have an open source project, that part of it is free. The Read the Docs thing has free support for open source projects, I believe, right?
Yes. So that's the real key here is, it's a bunch of boilerplate to set up. But once you're done, you've got something that's extensible and automatic.
Right. And I mean, there's definitely, some cool things I learned about here. Like if you think Doxygen docs look a little outdated, then you might want to look into Sphinx as an alternative. Or I say alternative, but Sphinx, as Simon says in the article, still kind of relies on Doxygen to get some of the information out of your code. Right. And the Breathe tool is just like a bridge between Doxygen and Sphinx.
Yeah, so Sphinx is a Python documentation generator.
Okay, so it can work with Doxygen, but it can also work with other forms of documentation generation.
I think Doxygen can dump out. I didn't actually see where the bridge happens when I was looking through this, but Doxygen has ways of dumping out like JSON and XML and stuff, so it must be picking that up.
Yeah, I think Doxygen, you configure it to output XML, and then Breathe is able to read that and pump it into Sphinx.
Right.
Yeah. Okay. Anything else? Do you do much documentation, Michael, or is that less of a concern since you don't have a public API?
I actually use Doxygen quite a lot, especially in the early days. And we actually use Doxygen in our project, even in the Factorio. But to be honest, I use it less and less. Basically, these days, I only generate Doxygen documentation when I want to see the, class layouts and sometimes other graphical layouts. And for any other things, I kind of realize that doesn't really help me that much because I can either see it in the code or it's too complicated to have it in code, and then we have separated documentation. So because in the very early days when I was 15 years old, I had this need of there's Doxygen tool, it can generate documentation and it can give me warnings for anything that I didn't document. And then I went through the trap of trying to document absolutely everything because I want to, I'm this kind of completionist. So I wanted to document every method, every functions, and I had these kind of methods of get X and document gets you X and things like that. And took me some time to realize that it's really not needed. So at this time, I'm starting to not see the advantage of using system like this anymore, actually, to be honest. Other than seeing graphs of classes and graphs of calls and things like that.
Right.
But maybe you can explain. Maybe you can change my mind. I don't know.
Well, it's interesting because I've talked to a few people recently who consider I'll see if I can explain this how they do, that having documentation in your code is in a sense a bug, and that is because if you needed documentation, the code could have been written more clearly. Like stronger typing, better function names, better parameter names, then you didn't need the documentation. I don't know if I fully agree with them, but I find it an interesting standpoint.
I think I would agree with that if you're talking about some internal project where it's only the developers that would be looking at documentation or looking at code. But if you're making some type of library that you want other people to use, then having documentation seems like it's still a good idea.
Yeah.
Well, I think that I kind of agree with the idea little bit, but still there are cases where you just need to explain the meaning behind things, and you can't just put it into variable or class name because it's just a little bit too complicated. Like most of the time, or you want to give a note about a variable or method, some note that might be interesting for someone trying to understand things, but I don't know. I think this is a little bit too strict. It's an extreme idea as well. I kind of agree that. For example, the typical example, when you have a block in your function and you put a method, what is this block is doing, then it's kind of obvious that let's put it into method and use the command in the block as the name of the method. These kind of cases are obvious, but then they are, in the real world, how it goes.
Yeah. So not one extreme or the other. No reason to document every single thing and be willing to document when you need to.
Yeah, my experience is that it's really important to document as little as you need, but you don't really know what's understandable and what's not. So it's a great opportunity when you have a team and someone new comes to the team to listen to them, and whenever they ask about something, how something works, then this is the place where you look at it and you think that this is the place that needs documentation, because the feedback is really important, because it's not possible for the author of the code to understand what needs more documentation and what's not. Or if you look at the code 5 years after writing it and all the way, you'll be.
Yeah, that's the worst one, when you read your own code and you have absolutely no idea why you did that.
Yes.
Yeah.
Exactly.
Okay, and this next article we have is on the Trail of Bits blog, and it's fuzzing unit tests with Deep State and Eclipser. And this is a pretty technical post, and I'll be honest, a lot of it seemed to go over my head because I don't know too much about fuzzer tools. Jason, did you have a chance to read through this one?
I did.
Okay.
Although I have to admit also some of it went over my head because I don't know, I don't understand all the technical details about how the fuzzers decide the things that they're going to do.
But the TLDR is they have a new fuzzer called Eclipser, and they've now integrated into their testing tool, which is called Deep State. And they found several examples where this Eclipser fuzzer is, far superior than some of the other ones that they already have integrated with Deep State.
Yeah, and I think a good takeaway is right from the bottom. They say, like, Eclipser's not going to remove the need for other fuzzers. Every fuzzer does something different. So they say, like, you should be testing your code against all of the fuzzers.
Right.
Because that's how you're going to actually find the bugs that matter, which is just crazy. Like, I didn't even realize there were, like, I knew there was, like, 2 or 3 fuzzers. I've used them. I didn't know there's, like, 6 fuzzers, and I didn't know that this Deep State thing had them all automatically integrated in with, I think was it G-Test or Boost Test? Sorry, I missed that bit here. Or I forgot.
I think they compare Deep State to Google Test.
Oh, okay. Well, I mean, it's got the same kind of syntax. That's what it is.
Yeah.
And it can just kind of automatically do these things. Anyone who's interested in fuzzing automated code testing really needs to read this article and check out Deep State. That's the real takeaway.
I would actually like to know. I would like to learn what does it even mean, because I don't know what's fuzzing. I never actually encountered it.
That's a great question, and
yes.
I don't know when we last talked about it on the show. So with fuzzing, if you have an input that can take any kind of data, it doesn't matter what kind of data it is, you want to run it over all of the possible types of inputs. So I've done this with ChaiScript with my scripting engine. I can you can use a fuzzer to generate a blob of data. You pass it to the scripting engine, and then it just tries to execute it. And the fuzzers use code instrumentation with like code coverage metrics to determine what functions have been called with the input that you gave it, and then with the input that it generated. So then it generates new input, and it starts breeding input files against each other, and all the while trying to execute more and more of your program based on its code coverage output.
So it's basically it's like learning what to give to the program to execute all the paths automatically.
It is, yes. And then
that sounds cool.
It's really cool. And the key is to enable it with something like Valgrind, which would slow it down an awful lot, but better is address sanitizer with Clang. So if at any point the input that it gave you were to generate some sort of memory error, you get an immediate crash with a stack trace, and you know what happened. And now you have a bug that you have to go fix because you have a potential security flaw in your code.
Mm-hmm.
I will tell my students, I did all of the things right. I was using all of the unit testing, all of the warnings on all of the compilers, all the static analyzers, and I knew that ChaiScript scripting engine was perfect. And then I learned about fuzzing, and in the very first test, I crashed my parser because I never tested handling an input length of 0. And then after a week or 2 of running with fuzzers, I decided ultimately I had to rewrite the parser because it was fundamentally broken.
Oh, wow.
Oh.
Yeah.
We should find someone who could do a whole episode on fuzzing, because it's something we've referenced a few times, but we've definitely never gone in depth on it.
Oh, yeah, and I believe we have contacts who can get us in contact with people who implement these fuzzers and stuff, too.
Yeah.
Okay. Definitely interesting thing that I have to study now after the talk.
Yeah,
okay.
Sometimes when I'm teaching this in a class, I have my students all stop and kind of look at each other and like, we have a problem. We have to go do this right now.
Okay. So, Michael, we've already made a couple references, but do you want to start off by just telling us a little bit about your game?
Well, the game, actually, it's kind of interesting because not only the programming the game, but also the game itself reminds a lot of concepts in programming, actually.
Okay.
Because the game, it's basically a game about automation, which is also programming is also about automation. But it's a game about automation even for non-programmers or people that don't even want to do programming at any time in their life. But basically the game is about a guy who crashed on an alien planet, and he is there alone, and he needs to survive. And his only tools are basically in the beginning he has to do everything manually, and then he can make simple machines and then use these machines to make products for him, and then he starts to build eventually a small factory, and then he starts to build a big factory. But since it's just one player, everything needs to be automated. And if he wants to expand more and more, and in a bigger scales and make more different products, he needs the parts of the factory to be more and more autonomous. So anything you do, you need to think with the thing in your head that you are only one guy, and you need to really think about your time and how to invest it. Because almost everything can be automated at some point, but you need to really think about what has the best, like how can you, what saves you most time with least effort, basically. And this is kind of the similar what we do when we do programming or anything related to computers, or even in real life. Like, where is the threshold? Like, can I don't know, do I spend half an hour doing a script that saves me 5 minutes a week or not? Things like that, basically. So, and we try to, and then we took this idea and then we try to wrap it into a game that would be actually fun. And we were really curious in the beginning whether something like that could be actually fun for people, because we enjoyed it a lot, but we had no idea if actually enough of people would enjoy that. And it's luckily enough, actually it worked, because obviously it's not a mainstream game, it never will be, but it's way more mainstream than we could ever anticipate, because we didn't try to make it like hard, like we didn't try to make it look elite or something like that. Like you can understand, if you can play the game from beginning, you can understand the concepts. The basic concepts are super simple, and if you want to play the game in a simple way, you can finish the game in quite simple way. And if you want to play it complicated, if you want to make complicated system, you still can do it. So people kind of enjoy it. So you told it. It's sold like in the beginning we were like, oh, if 10,000 people buy it, it'll be super crazy. And now we are here with 20 people on the team. So we're doing it for 7 years. So it's kind of the definition of when it's finished is changing all the time. Because in the beginning it was supposed to be finished in half a year. It was half-year project, and now it's 7 years. But there are many aspects of this, and mainly like you finish, you go one iteration through the game, and then you're like, your standards gets higher, and then you do second iteration, third iteration, then the game grows, and then everything, like the kind of a problem of the game is that it has like many aspects. It combines many different games. Like there's logistics, which means like basically you have many parts of, for example, Transport Tycoons included. Then you have like technology and some kind of combat. So we have parts of real-time strategy or civilization of this kind of gameplay included. And then you have crafting, and so it's like partially like some industrial games, and many other small things in between. So basically there are a lot of different systems in the game, and as they grow and as each of the systems are improved, over time, then it takes more and more time to improve all the systems at the same time, and they all are interconnected. So it's really like starting to be quite a big project. And I think that I'm saying it sometimes that when you see a game, you can very often you can clearly see, especially if it's in an indie game, if the game was started by a programmer or by a graphic guy. And here on this game, you can clearly see that it was started by a programmer. If you see all the system that are moving and everything going on. So yeah. Mm-hmm.
You said it's kind of like programming, but not really like programming. Like, what does this look like? How does the game player like automate things and program the system, I guess?
Well, for example, I don't know, like the first thing that you encounter is that you let's say you mine coal, mm-hmm. and you mine it by hand, and then you make a first machine that runs on coal and can mine, and for one piece of coal it can mine, I don't know, 7 pieces of coal. And then the first automation is that you put the output of the machine back to the input of the machine, or you put two machines next to each other so they feed each other by coal, and suddenly like the two miners, like you know what I mean, like the output of one miner is put in as fuel into the other miner, and,
right,
and from the second miner to the first one, and suddenly you look at it and you made your first like little super simple automation, and it continues like that. Then you have transport belts. So you start like in the beginning, you hoard on one place, you hoard iron, on second place you hoard coal, and then you start using transport belts, and you move these two things to the same place and automatically put them in the furnace instead of doing it manually. And then you play for some, and then you always take the finished, iron plates from the furnace and do whatever with them, build some machines. And then after some time you learn that it's better to put the iron away from it and build the products you do manually automatically, and from the iron plates you make, another transport belts and other inserters. So like basically in the beginning, the main products of the factory are other pieces of the factory, so it feeds itself.
Wow.
And basically the programming part is that, for example, you always like as the typical experience of people is that they start building the factory, and after 2 hours they realize that it's a horrible mess. They can't extend it in any way, and they had to start over and think like, okay, no, not now. I will build it properly from the beginning. I will leave space for extension of all the system in the factory, so I can expand and scale it up. And after 5 hours, I figured out that I didn't prepare enough, and I just start again. So this is the typical story, which sounds very familiar when you think about it. and by iteration, you learn how to scale things up, how to prepare for like how to divide the individual systems, and how this all I think is similar to programming. And there's obviously much more. And the more complicated the factory is, the more you need to prepare before you start just doing the buildings. And obviously, even if it's a shitty factory, even if it's a messy system, you can still finish the game. It's just going to be a horrible experience.
That really does sound a lot like programming.
Yeah. So I want to dig more into the technical aspects in a minute, but I'm just curious. You said you can finish the game, fairly quickly, or you can take a long time building up your factory. What is the end goal? Like, are you trying? You said you're an astronaut that crashed on this planet. Are you trying to build a new spaceship to get off?
Your goal is to launch a rocket into space.
Okay.
And for some people, it's just a beginning, because launching the rockets allows you to do infinite research, and then people just make huge factories for then they basically, for some people it's the end of the game, but some people, they call it rockets per minute. Like, how many rockets per minute can you launch? And then people like put their crazy numbers, like I launch 100 rockets per minute. And someone like, no, you need to push these numbers, you need to launch 1,000 rockets per minute, etc. So it's basically like we really wanted to have it to make end to the game, because when the game is really like you have no goal from the beginning, it's kind of weird. It's like too open for my taste. But even if you finish, very often you just want to finish and scale it bigger and bigger.
Okay, and it sounds like you can get the game now in early access, but does the game have a final release date planned?
Yes. Well, we are. I think for like 3 years we are saying that it's going to be this summer or the next summer. But I think we are now really like trying to finish it. But basically, the game it's in early access, but I would say it's quite stable, because we have this stable and experimental release cycle, and the stable releases are kind of, I would say, very stable, because it's played by a lot of people. So, and we try to fix as many bugs as we can. So the game is stable, the game can be finished, and it contains almost everything that we wanted for the full game. Basically, now we are polishing stuff, like making more understandable UIs and making better tutorials and finishing the graphics and everything. But I think that it's not like a half-finished game at this point.
So I'm curious about this timeline, because you said that you originally thought the game would be done in 6 months, I believe is what you said.
Yes.
How long did it take you until you actually had something released on early access from the time that you started?
Well, if you mean early access on Steam?
Yeah, or whatever. From the time that you started to the time that you were actually selling it.
The thing was that, I think we took something around a year and a half before we started a crowdfunding campaign.
Okay.
Basically, me and my friend, we saved some money and moved together to an apartment. We were working like 14 hours a day, 7 days a week, something around a year and a half. And we were both quite, like, I would say, experienced C++ developers. At least we had both like some experience from companies and did a lot of projects, etc. So we were working on this, and after 1.5 years, the money were starting to dry out, and so we needed to. And also, we weren't sure if, as I said in the beginning, we weren't sure if actually someone would enjoy it, if it's not just us who like the idea.
Right.
So we needed the money, and we needed a reality check. So this is why we made the Indiegogo campaign, and you have like these two kinds of campaigns. You can either have like whatever money you get the money and you do the best you can with the money, or you can have like a strictly specified minimum goal, and if you don't reach it, you don't get any money. And it sounds like the second sounds like it's not as good as the first one, because you risk that you get nothing. But we preferred that, because if you have some estimation of a budget and you get half of it, what do you do with it? Like,
right.
So it would be the worst. So we specified a goal that at that time we thought that would be enough to finish the game. Like, I think it was like 17,000 euro. And
okay.
which sounds funny, but
yeah, not a lot.
Yeah, it's not a lot, but we were living both two guys in an apartment in Czech Republic, eating cheap food and like not really having many expenses. And it was really like we really thought that we will finish it soon. So yeah, and eventually like the campaign it's a story of its own, but eventually we passed the campaign at the end, and we thought that everything is going to be fine. But so it was after 1.5 year, but we still like basically after campaign the like any people didn't buy it anymore. Like they bought it, they were buying like during the campaign we made a web page, and there we started selling the game directly on our web page. But 2 days after the campaigns, like the hype basically died out. And we saw that we can finish the game. We hired one of our friends, so we are like 3 programmers and 1 graphic, and suddenly the sales went to 0 for several months. So it was tough time actually. So and then in this time we were mainly working on like on the backbones of the game, but then we realized that like the graphics is important for selling it. So then we started improving the graphics more, and realized what's wrong, and slowly, step by step, the sales on our page were increasing. I think after like 2.5 years, we got to a stage where we could like live we could have a very humble life paid from the game, really humble, but yeah, something around that. Okay. And then it was, and basically we didn't want to go to Steam, and this too early, because from what we made some research, and we found out that the first release on Steam, whether it's early access or not, the first time you appear on Steam is the most critical for the game, and you really want to be ready for that. And if you invest like half a year extra to polish the game more and do the release later, it's really usually worth the trouble. So we actually waited 2 more years for the Steam early access to really like use this opportunity as much as we could, and it really paid off a lot, because I think that I think in the first week of being on Steam we sold as many copies as all the 2.5 years before combined. So it's really like it really pays off to do the first impression properly. That was our takeaway. Sounds
like a really important lesson.
Yeah.
Yes. Actually, there are articles about it. Basically, I don't know if you know about Steam Spy.
Mm-mm.
It's because the problem with Steam and the sales, this is more about games than C++. It's not public how much the games, how many copies of the games are sold, and how is the what is the graph of the sales, etc. But some guy discovered that people like share what games do they buy on their profiles, And basically what he did, he made a robot that went through individual profiles of gamers, basically random profiles of gamers. And he made some statistics that if he discovered like 0.1% of gamers, he could make a rough estimate of what are the sales overall.
Wow.
So basically this unofficial page is making like statistics of sales, which is kind of interesting. And then there are like interesting articles about takeaways for indie devs. And basically he discovered that basically people thought that early access is like one big chance to make a big sales, and then people thought that when they go from early access to full game, that it's even bigger, or it's like second chance to make the same kind of impression. And from the statistics, it looks like it isn't like that. Like when you go from early access to full game, you have some kind of bump. It helps, but it's nothing compared to showing the game for the first time.
Right.
So it's just.
Okay. I want to interrupt the discussion for just a moment to bring you a word from our sponsors. PVS Studio is a tool for detecting bugs and security weaknesses in the source code of programs written in C, C++, C#, and Java. It works under 64-bit systems in Windows, Linux, and macOS environments, and can analyze source code intended for 32-bit, 64-bit, and embedded ARM platforms. The PVS Studio team writes a large number of articles on the analysis of well-known open-source projects. These articles can be a great source of inspiration to improve your programming practices. By studying the error patterns, you can improve your company's coding standards, as well as adopt good programming practices which protect from typical errors. For example, you can stop being greedy on parentheses when writing complex expressions involving ternary operators. Subscribe to Facebook, Telegram, or Twitter to be informed about all publications by the PVS Studio team. Links are given in the podcast show notes for this episode. So let's start digging into some of the technical stuff a little bit more. Mm-hmm. Are you using any like existing engine or graphics libraries that we would know about, or did you kind of build all that stuff yourself? Okay.
As I was talking about the DOS times from the beginning, I don't know if you remember, there's this library called Allegro. I don't know.
Okay.
Did you hear about it?
I have heard of it. Yeah.
Yeah. It basically has roots in the old times, like in the DOS era, basically. And somehow when I started doing Factorio, it was I checked if it still exists, and it still existed. So basically, all I wanted from an engine was that draw me a sprite and play a sound. That's all I wanted. I didn't want to use any. I made them like really fast test of what engines are they available. And the problem with Factorio is that from the beginning it was super clear that we will need really good performance, because the game is based on automation, and the interesting parts of it emerge only when you have big enough factory. That's the time where it starts to be interesting, because you need to manage all the mess. So, and I needed all the factory to be running. So it was very obvious from the beginning that it will have to be optimized a lot. And I was afraid that if I used an engine on the market, I would basically at some time I would hit a wall, and there would be no way for me to overcome it. So I wanted to have everything under control. This is why we use Allegro basically just to draw a sprite and play a sound and read from keyboard. And everything other than that was written by us. And actually, like a year ago, we actually moved from Allegro to SDL.
Oh.
But it's not really like, it's basically just a big, it's not that big part of the code being changed, because most of it is like, the game logic. Basically.
Right. So both of those pretty much just give you a place to draw some pixels and some I/O, basically.
Yes, basically. And actually, like we spent a lot of time with optimizations while doing the game. Basically, the cycle was that once the game started to be public, people made as big factory as they could, and then they complained on the forums that it's starting to slow down. So we were like, okay, so let me look at it. And then we've optimized the game with the safe as a reference, and we optimized it enough to make it, like, for example, twice as fast, so it's smooth again. And we put this into the next version. And the next version, people realized that they could build a bigger factory. So they made suddenly 2 times bigger factory, and then they complained again. And then like this, we basically, we went through several cycles like this. And the good thing about this is that suddenly we could optimize with a reference to real factories and not, against some theoretical things. So I think it's like there were many steps like that when we made it 2 times faster. And with C++, it's really like, this is where I was happy that we chose this way, because we could do really interesting things. And obviously, like, the further we got, the more sophisticated tricks we had to go. Like, the low-hanging fruits are kind of depleted. So, yes, so it's like that.
So this game's been in development for a while now that you've said. You've watched several new releases of C++ basically come in. I mean, new C++ standards. What standard do you use? Have you morphed what compilers you require and what standards you use along the way?
Basically, I remember the time when we adopted C++ 2011, or C++ 11, and we were really happy with that. Because one of the problems is that we do Linux, Unix, and Windows releases. So whenever we want to use something, it needs to be supported by all of the compilers that we use, which kind of slows things down. But for example, in the beginning, we used Boost. And I still remember the moment when we removed Boost for each by the C++ 11 for each, which improved compile times by like 10% or something. So, yeah, it was really crazy. And for example, one of the things that we used Boost at these times, and I think since C++ 14 or something, we got rid of Boost eventually completely.
Okay.
And the main motivation was compile times, because, and we will probably we can talk more about it, but basically my biggest complaint about C++ overall, it's compile time. It's basically tightly related to the include system and compile time. They are like the worst cancers of C++. And I think I wrote somewhere that like if you include like string or something, you include like, or IO strings or something, you include like millions of lines of code in single include. And I remember I was doing tests like doing 500 CPP modules that were completely empty and just included one string or something like that. Even with this precompiled headers, it started to compile like half a minute or even more. So, and when you see this, you start to be desperate, because we were trying to optimize our include structure and forward declare everything and etc. But if you know that just including string makes your compilation that slower, that's kind of desperate. So over the years, like when we started using C++ 11, it started to be better, because since we got rid of Boost, it was better. And then basically once a year, someone was too annoyed by the compilation times, and they tried to make something like, for example, the last time when we were doing it, we discovered Fuzz build. I don't know if you know that. Mm-hmm. You know Fuzz build?
Yes.
Yeah.
It's without that, it would be really horrible. Basically, when we adopted Fuzz build, they include in compile time improved. Basically, for the people who don't know what Fuzz build is doing, it's basically doing how's it called? Like, it's trying to solve the compile time by putting things into modules. Like if you have 1,000 modules, they group them into modules with the ideal count, because if you like group, I don't know, every 10 CPP files into one, it means that the preprocessor doesn't have to process the include files again and again in every module. So if you put then it's makes some other optimizations. And basically with Fuzz build and a lot of hacks, we are now, I think the recompile time on debug is something like 2 to 3 minutes, which is not that bad for a whole project like this. But still, like every second you have to wait, every time when you compile, it's adding drag to development. And basically this means that as the project gets bigger, the development gets slower, not only because it's inherently more complicated, but also because of this. And I think that like sitting there and just waiting for it to compile, it's really horrible. So this is our biggest fight, I think, with C++.
So are you currently on C++ 14 then? Is that what you said?
I think we are using, to be honest, I'm not really actually sure.
Okay.
Because, if we are using 14 or 17, I think usually it works in a way that we are trying to use the latest compilers. And I think that this kind of on which C++ version you are is kind of bending now, because yes, there are like standards
Right.
of what is C++ 17, but in reality it's about what is supported by the compilers. So
Right.
usually it works in a way that someone's like, oh, there is this cool C++ feature, let's test if we can use it, and we make a branch and we try to use it and see if all the because we have automated testing of branches, etc. So we test if all the compilers can use it, and if so, then we'll say, okay, so we can use this C++ feature. And so this is usually mainly the reason why I can't tell. But
that makes sense. And for our listeners, because you didn't explicitly state this yet, you support all the way back to Windows XP, Ubuntu 14.04. Is that right, according to your GOG.com page?
I think that we dropped XP already.
Okay.
Because we dropped 32 bits like a year ago or something.
That's fair, I think. Yeah.
Yeah, because it was too annoying to solve all the problems. Because one of the like, we have several constraints, and one of the constraints is that our multiplayer is based on deterministic lockstep, which means that the logic of the game needs to be fully deterministic, which means that any small change in behavior on different machines in the multiplayer causes desynchronization, and it just can't happen. Which means that a lot of things can get broken. Basically, like, I don't know, you make a std set of something based on pointers, which is normally something you could do easily, but here you can't, because the order would be different on different computers. Like, many different things can get broken, and with 32-bit versus 64 bits, there are also a lot of small details where you need to be careful. And basically, this is why. And I think that based on the research, it like less than 1% of people use 32-bit systems. So it was it's not supported anymore.
Right. One thing I'm curious about is I saw on your forums that you allow mods of the game. Did I read that right?
Yes. Well, that's one of the reasons why I wanted to support mods from the very beginning, was that basically one of the games I came from was the Minecraft modding community. I mean, I wasn't a modder, but I was playing with mods basically. And when I looked, I don't know how it is now, to be honest, because I didn't have time to play the game for years. But before, the modding, it was really wild because, for example, I don't know, the game didn't have they had numerical constants for things. Like, for example, you had ores, and they had to make consortium of mods where they made a spreadsheet of what IDs of different ores used what mods, so they don't have conflicts and things like that. So the people really had to cooperate outside the game to make things compatible. Okay. And that looks like not really a good system. And also basically I like to modding in most games. Like in Baldur's Gate, modding is really great, but also it's this for a user, it's really horrible experience, because you have these pages and pages of scripts of how the modding needs to be done, and what is the order of the files and all the special operations. And once you start playing with the modded game, you can't ever change anything because it gets broken. So basically, we put the constraints on the game that the modding should work in a way that you can, at any time, you can add or remove mods. When you have a save, you can add or remove mods, and it needs to just work. And when you remove when some objects from the mods are not available anymore, they just disappear from the save, but you can continue.
Wow.
And that also that the mods obviously shouldn't be able to break the game in a way that you don't understand what broke it, which is the second most typical problem. Like, for example, in Oblivion modding, where the typical thing was that you just put more and more mods, and suddenly the game started crashing, and then happy hunting. Yeah. Like, what do you do? And when you change the mods, like if you want to, for example, bisect the mod list and to find out which mod is causing it, you can't really do it, because when you remove the mod, you break the save game. But to get the save game to the state where it starts crashing again takes you 50 hours of gameplay. So it's virtually impossible to find out what's wrong. And this was so you can see, I had so much frustrating experience with mod that I wanted to make it right, which is adding another huge constraint because you need a deterministic game and you need to mods like this where you need to be able to remove and add mods at any time during the, like not during while playing real time, but during one playthrough basically. So, and the mods, also the mods are one of the things that I think was a mistake is that we use the Lua language for mods. And from my experience with Lua, I didn't have experience with Lua before. And I'm not really happy with that because Lua has basically it has like three fundamental problems. One is that in Lua you can't really deserialize and deserialize the state of the state. So basically you have a scripting language, but the scripters, they need to work properly to not desynchronize the game in multiplayer, which is really weird because if they do it, it's like I mean we have a guide for them, which is not that hard to follow, but still it's really like something like good scripting language should be able to serialize its state completely, right? The second problem with Lua is that it indexes things from 1, not from 0. It's like if I could count all the places in the Lua to C++ transition where it's like +1 or -1 to make it compatible with Lua, it's like really crazy. The third thing, biggest problem is that in Lua, like everything is global by default. Like every variable you need to explicitly say it's local instead of otherwise, which I think is really weird. Like you make this one little method, use this variable, and you don't use the local when creating the variable, then suddenly it's global. It's kind of strange. So, but we didn't realize all these problems, so we just are trying to kind of living with Lua. On the other hand, a lot of people are used to that, and they are. But if I was to make another game, I would definitely try to use something else. Either some other language, I don't know, maybe if there's some good script. Basically, the best scripting language would be if it was strictly typed, C++, for me at least, but I don't know if it even exists actually.
Well, Jason might have a scripting language to recommend for you.
ChaiScript.
It's the ChaiScript language.
Yeah, ChaiScript is strongly typed, and it is one-to-one typing with C++. Anything you expose in ChaiScript is a C++ type, but you probably would not be satisfied with it because it would increase your compile times, and it is pretty heavy on dynamic allocations.
I think that I saw you. Didn't you have a talk about optimizing ChaiScript?
I did,
somewhere?
Yes. Yeah.
I think I saw the talk where you. Yeah, now it's starting to connect in my head. So maybe it could be interesting to. I should check it up probably.
Sure, check it out. Yeah.
So basically, yeah, this is about the Lua. But for example, one of the great things that I like, I think it's really always for me to understand like what were the good decisions and what were the bad decisions. And one of the good decisions is that you in the morning you can define like your definitions in Lua, but the good things is that like the definitions of the objects are also programming language itself. Like it's processing a script that in the end it generates the tables that are then used as an input for the game of the objects, of definitions of the game objects. And since it's a programming language, it gives you huge power of, for example, you can have a mod that modifies data of other mods, and it can be done procedurally. So these kind of things are really, really nice.
Did you use any like Lua bind or Soul or anything like that to integrate it with your system? Or are you doing all that binding by hand with Lua?
Well, I'm just looking at the source code at the moment. We have Lua. I think I would say that we do it ourselves probably.
Okay.
We have some classes that do it, but it's written by us. It looks, maybe we started with some library, but it was written so many times that basically we even have our own version of Lua because Lua isn't deterministic actually. And we had to rewrite parts of Lua that when you iterate, I think tables or something like that, to make it deterministic.
Wow.
And also, yeah, because we just need deterministic simulation. It's simple. And also Lua was not deterministic on the same systems. Like for example, if you like in Lua print minus, I don't know, if you print minus 0, it prints different values on different platforms or the, like basically, all the like print functions give you different results on different platforms because the print has different implementation on different platforms. And so we had to do several things, or for example, the random function can be just a random function, obviously, if you want deterministic simulation. So it needs to be,
right.
And also the problem is that basically we need to simulate like objects in Lua because to the user, we are pretending that you have like structured data and objects, but it's not really like that in Lua. So we are doing some weird dark magic to try to make it look like that. And the problem is that, for example, in the beginning, we were doing things like, I don't know, you expose a class and we are like pushing all the possible, I don't know, methods and access points of the class. And the problem is that then again, you have the optimization constraint. And if we found out that it's slowing the game too much, like, for example, now we have to like prepare access tables for each object and then like you reuse them and things like that. Right? So there's like, there were also many iterations in the Lua API that we had to change and optimize. So basically, if I wanted to use scripting language again in a project that's so like constrained by optimization, you definitely would have to have some better access to structured data. That's like really fast. Like something that you said sounds really interesting. Like that you expose somehow C++, but you can't really expose C++ because you can't let the user do whatever. You still need to go through some API. But I don't know, something that's more like structured.
Yeah, that is part of the problem. I mean, and it's a trade-off. If depending on how much power you give the user, then you're giving them too much power into your system. You know, like how much do you need to sandbox it or whatever it sounds like is also something you have to be concerned about.
Yeah. Well, yeah, when it comes to modding, it's very clear. It needs to be, the user shouldn't be able to, but can't like be a threat to the safety of the application. That's like number one rule. And it shouldn't be able to crash the game or in unintended ways. So basically, if you just give him an object and let him do whatever with it, then basically you would have to check that all the values of the objects are correct. Or you need to just allow him to change any value through your API. I don't see any way around it because, as I've learned, like it's better to sacrifice a little bit of performance than have broken mods.
Right. That makes sense.
Okay, well, it's been great talking to you about all the work you've made on the game today, Michael. Maybe just one more question before we let you go. You talked a little bit about your criticisms of C++ with includes and compile times. Is there anything you would like to see added to C++ that might make it better?
Well, for example, like when it comes to includes, that there is this, I think it's called modules, right?
Yeah. Right.
There is this modules things. Then that's for me it would be the more important things than anything combined that's planned. And I know that it's in standard and it's, I think, experimentally supported by Visual Studio. I made some experiments and yeah, it is experimentally supported, but it's still way slower than even includes. So it's not like, it's not, I guess it's just, it's not in the phase where it would actually make things faster.
Right. Well, hopefully that part will get better when it's more of an official feature in C++ 20.
Yes, I hope so. I'm not really sure how it is like all the standard libraries would probably have to be rewritten to use modules.
Yeah.
And basically all the projects that want to use it would have to be rewritten in order to make it actually to provide the advantage of the faster compile times. But I would be like really happy if it solved the compile time problems, because that's for me is one of the biggest burdens. And for actually the thing I'm now kind of watching is the Jonathan Bloom's language. I probably heard of it, the Chai. Did you hear about it?
Jonathan Blows, I've heard about it, but I haven't looked at it myself. Yes. Yeah,
I watched several streams, and it looks like he has really interesting insights. And basically, the problem with I kind of see the problem even with the way the question, because question like what would you add to C++? And I think the biggest problem is that we are still trying to be backwards compatible, and we are adding more and more and more things on top of each other, and on top of and then when someone wants to learn C++, it's super hard. Like I'm programming in C++ for more than 20 years, and I'm quite sure that there are a huge amount of things that I don't even know that they exist, or I wouldn't understand what's going on because they are too obscure, or the language is just it's too complex, I would say. And it's not really necessary. It's just because we had to solve this problem of making compatible and basing it on language that's 30 years old. And I think it would really be interesting to either like try to adopt some new language, or maybe make like C++2 or something, and where people would just cut off the garbage and just make it backwards incompatible, and just try to like really move on, because this problem of always finding the local maximum, like improving the local things and just trying to get it a little bit better has its limits, and I think we are reaching them. I kind of believe that someone needs to be brave enough to try some bigger step. That's my feeling. Like but other than that, obviously the modules, if you want the simple answer.
Okay. I guess.
Go ahead.
I don't think you ever actually said the name of this game.
The game is Factorio.
Okay.
It's like factory and Factorio. It's like a Spanish kind of version of the word. Factorio.com is our webpage.
Okay, great.
Yes.
Okay. Well, it's been great having you on the show today, Michael.
Thank you for inviting me.
Thanks for coming.
Have a nice day.
You too.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@CppCast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/CppCast. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode was provided by podcastthemes.com. At CppCast.com. Theme music for this episode was provided by podcastthemes.com.